see the timer here.
Hello, everyone. Great to be back on day 2. I hope everyone's been having a great day so far, and we're all set for us day 2 during the exciting TestMu conference here for you all. I am Mohit, your host for this session today, joining you live from India. And let me introduce the next speaker from our star-studded list today. We have Vinayak Hegde in the house, one of the go-to guys for the technology leaders, technology CTOs, co-founders in the startup industry as of today. He's working as CTO in residence at Microsoft to assist startups do what India did to software industry in early 2000s, which is paving a path for growth and success. With about 20 plus years of experience, glistening the seat of many senior technical leadership roles, Vinayak has built a number of products across various domains such as IoT, large scale networks, data systems, you name it, and Vinayak has tried his hand at that. He has also worked with Akamai, Inmobi, and Zoomcar. In his talk today, Vinayak is going to explain how to reduce product failures by improving software quality using different techniques like observability, code profiling, code coverage, choosing the right language systems, static analysis, and language features such as assets and design by contract. So much to grab from Vinayak on this topic today. It's time for you, Vinayak, to take over the stage. Over to you.
Thank you so much, Mohit. I hope you can hear me all right, and see my slides as well. Cool. So let me start. As thanks, Mohit, for the introduction. What I'm going to do is, I'm going to talk about how do you reduce the production failures, and also with a focus on software quality. So let me start a little bit about myself. I think so. I have about 2 decades of experience in technical leadership and individual contributor roles, and I've worked across various kinds of systems, distributed systems, large scale networks, large scale data, IoT, and machine learning AI. And also a variety of systems. I've worked with networking, developer tools, ad tech, e-commerce, media and smart mobility. And currently, I'm working with as CTO in residence in a global world at Microsoft for startups. And as part of my job, I help startups actually with product strategy, with scaling the architecture, scaling their teams, org design, choosing the right tech stack, and so on and so forth. Right. So that's about me. So my background. So without further ado, let me get into the let me tell you a little bit about what I'll be talking about in this talk. If you look at the software lifecycle, there are different stages, and then we kind of iterate through these different stages. Just give me a second. So for the first stage, obviously, is like we write code, and we can. I'm going to talk about when we write code, how do you choose a good language system? What are the different features? Then once you have built, if it's a compiled language, then we build it. If not, then we test it, and then we go to the QA and quality assurance cycle. Then the next one is we do a deploy, which is like the CI/CD, pushing the code onto production servers, restarting services, and so on and so forth. And finally, once all of this is done and everything is tested, I think it isn't you are in production, right? So what I'm going to focus is more on the first part, which is code, and then the last part, which is production, because I'm sure that other speakers have talked a lot about the build and test and deploy. But I want to talk about it holistically, and then I will touch upon build and test and deploy a little bit. But mostly, I would going to talk about code and production, right? So without further ado, I think let me jump into the first part, which is code, right? So these are the 5 different things that I'm going to talk about. How do you choose a language? What is design by contract? What is programming safety? Linter, static analysis, and then finally code profilers. Okay, so I when I work with startups, I often get asked, how do you choose a tech stack? So when you're starting up, actually, what happens is like you want to kind of build really fast and then not have like complicated setup, right? So typically, you want the language itself and the tools itself to be malleable, right? So most startups actually start with like Ruby and Python, or any new tool. Even in a large company, want to experiment, I think these are like good tools. And then once I think the product features added, products are becomes big, the more it becomes a monolith, then slowly it's broken down into microservices, and typically these are written in statically compiled. So whenever like people start off with like once one I tell them is, hey, choose a language which is like one of the dynamic languages like Ruby, Python, JavaScript is another good example, or choose another statically compiled language, C, C++, Rust are like popular choices there, right? C sharp as well. And again, both have trade-offs. Like a workman's tool, you have to use the right tool for the job. Like for example, if I'm building something in the backend, statically compiled actually gives me the compiler does a lot of work and tells me certain things if they are wrong, and it does a lot of background work, right? So I'll talk about two design philosophies which you might or might not heard of, but somehow they're making their way into the rest of the language ecosystem, right? The first one I'm going to talk about is what is known as design by contract, right? So what is design by contract, and what are the languages that implement it, right? That few languages that implement it, and slowly we'll see some of these concepts are making their way into other languages, right? That is how the programming language ecosystem evolves. So we'll see that iFeel was one of the first languages. It's not very mainstream, but that was the one that came up with some of the design by contract. And then I think among the mainstream languages, you have Clojure and Scala and Kotlin, which are using that. So basically what so the design by contract, what it does is the notion of a contract, right? That extends down to what is like a procedure, method, or a function level, right? So every specific function has a contract, and what does a contract consist of? Consists of a following pieces of information: acceptable and unacceptable inputs or values and their meanings, return values or their types and their meanings, error and exception condition values or types that can occur and their meanings. Side effects are typically anything that has an impact outside the method. For example, global variables, any kind of input output, any kind of network activity, all of these are like side effects. And there are certain preconditions that are met. So preconditions are like conditions that need to be met for the function code to be executed, and post conditions are basically once the function and the code is executed, what are the things that need to be actually true, right? So any kind of setup that is required. And then there are invariants. Invariants are basically things that should not change over a period of time. So this is like good philosophy, and why this is important is because it provides because you have a strict contract between the caller and the callee, the function that calls and the function that is actually executes. There is some kind of handshake, and because there is an agreed contract, it cannot outstep it. You can't do random stuff, right? Because if you do random stuff, either the preconditions or the post conditions would get violated, and then there would be either be an exception thrown or there would be some log. So basically it is a good way, it provides a good structure for you to actually build a library of function and compose your software. um, and then the next one I'm going to talk about is programming safety, right? So if you look at the overall landscape, the bugs that are there, especially with old software that is written with C sharp, or that is written with sorry, not C sharp, C or C++, then there are a lot of issues with memory safety. There are memory leaks. In fact, when Microsoft did a research of this CV database, or common vulnerability database, that is that CV database, it found that almost 70% of the errors that can be caught, and again, like testing also helps catch these errors, were of memory safety. And the rest could be caught by by either using by checking for thread safety, which is like when the function is actually set up and then actually is called, there should not be any any change in context. And then there is type safety, right? So if I were to use another language as an example, I talked about ifil. Another language which is like getting very popular now is called Rust. It has a steep learning curve, but Rust is like very memory safe and goes out of its way to make sure there are concepts like ownership, ownership of a certain memory block. And there is a concept of borrow and checker, right, which is used to actually check that whenever you're using a memory, whenever you're using any kind of memory chunk or any kind of variable, you have the ownership, and the borrow checker kind of actually enforces that. And again, like there, it is null safe, type safe, and thread safe by design, right? So Rust is a good example of a language that has actually taken all the mistakes that have been made in other languages, and all the testing framework, and then actually does. But what it means is the compiler does a lot of work upfront, right? So when you are a developer, the downside of this is because the compiler does a lot of checking and work upfront, the compilation is actually a little slow. But then because it has no GC, and it has this concept of borrow checker and ownership, you can be guaranteed that what is written, what you expected from the language, works as designed. And that is what you always want, right? You have a mental model of how the code should work, and then you kind of fit it to the programming language, and eventually it runs. If there is any difference, and that is what causes errors, or that is what is caught in exceptions, or that is what is caught in the test, right? So it makes sure that your mental model and the programming model that is there is actually very close, right? A compiler actually makes sure that is there. Another good example of code is linters, right? So there are two types I'm going to talk about here. One is like a linter, which is a tool that analyzes the source code to flag programming errors, bugs, stylistic errors, suspicious construct. So they typically perform checks like, is the indexing beyond arrays, right? This is a very common problem that you have in C and C++, that you index something, and then you're trying to dereference memory, and it's basically because the way C is designed, you might have issues. And then you don't want to, if you're using pointers, you don't want to dereference null pointers, because that can lead to program crashes, and also potentially dangerous data type combinations that could be that are unsafe. Basically, for example, you have one variable, and then multiple maybe threads are writing to it, or it is getting typecast to different, that memory chunk is getting typecast to different kinds of types. That is also problematic, right? Why? So you can see sometimes people do all of these nifty tricks, but challenge is, if you're trying to be clever, sometimes it can bite you back. Or it could be like code that is written, but because of the conditions in which the code or the program operates, the code is never called, right? So it's unreachable. So this is typically known as like dead code, right? And compilers also sometimes actually are very good at finding this dead code and then eliminate it. So there's a specific kind of compiler optimization that is called as dead code optimization that can be used for this. And there could be some amount kind of non-portable constructs. This could be either platform specific, or there could be something related to enums. That might have these issues. And there are various examples, right, across languages, right? For example, if you look at and linters go from do everything from finding just formatting the code, like go FMT or SFMT, to actually linting and doing a little bit of stylistic checks, or figuring common errors. But these are very whatever they are very inexpensive to run, and because they do not take a lot of time, they are very easy to add to a developer workflow, right? For example, if I write a piece of code, or if I write a file, or if I write a function, I can just run once just before I'm ready to commit. I'll probably run a linter, and then actually see what errors or flags it generates, and finally once I'm satisfied, then I can check in the code, right? So it's very fast to do, but again, it's very limited in functionality, right? So and again, like most of these languages have like linters, and these work very well. So if you're not linting your code, you should obviously do it, and also tell a little bit of a reference to why it's called linter. Like, for example, when you wash clothes, you might feel that sometimes there is lint on the clothes, right? So there are, like, even in a washing machine, you might have like pouch or something that makes it easy to remove this lint. And basically all of these chinks, small chinks that are there, that are removed from the clothes. And similarly, the code linter actually removes all of these small chinks and makes it easy to do. So it does everything from, I said code formatting to checking specific language constructs. And these are again like very very language specific. A slightly more advanced way of checking code is like static analysis. So static analysis is more involved, because what compared to a linter, what static analysis does is actually it parses the code. Sometimes it might run parts of a code in isolation, like in some kind of sandbox, right? So they might what the static analysis does, it maybe runs a program parts of the code. So they will find things like, okay, what code is, again, like similar to linter, what code is unreachable, what code is likely to cause security issues based on some kind of patterns. So they can now the newer ones actually have pattern based recognition to figure out problematic code. And also now they also incorporate AI to find out like patterns, right? So they can use like neural networks and see, hey, this kind of pattern has resulted in this kind of issues. So basically, I talked about the CV database, right? So they can go back and see, okay, what are the kind of patterns that have led to issues, and then are those similar kind of patterns in the code, right? So it will flag those patterns, and it also will look at certain kind of quality or complexity metrics. Complexity metrics is could be like something like a cyclomatic complexity. What kind of functions are called, what is the sequence in which they are called, are certain functions calling each other, is there a proper exit condition. Those kind of issues can be fired out, right? So cyclomatic complexity is another good way, right? So if, for example, if we have recursion, and then there is a lot of recursion, for example, tail recursion, then it can actually flag that, saying that, hey, this is not like a best practice, and this is not recommended to have in the code. And again, like, it can enforce certain kind of, as I said, like design by contract kind of or annotations that need to be there in the code. If they are not there, then it can kind of incorporate, it can help you incorporate code, right? So if you have, for example, certain kind of standards that you have in your organization, you can enforce them both in static analysis or linters. And also there are certain static analysis tools that you allow for some out of the box certification for safety critical systems, especially in an embedded world where you cannot change the hardware very fast. You have These are very, very critical, right? Because once the code is actually flashed onto the firmware, and it could be something like a fridge, it could be something like a car, it could be something like a spaceship, it could be a range of things, right? So anything that is like safety critical, you tend to have, like, the static analysis tools added to the workflow. And again, like, because static analysis does a lot of work, it parses the code, it builds a what is known as a AST, uh, um, you know uh, so it does take time to run. Most of these tools, they do take time to run, because the amount of analysis do is much more. So I think it is somewhere between, I would say, a compiler and a linter. And if you look at something like Rust compiler may not do static analysis, but internally it does something very similar. It actually figures out how the memory ownership is changed, right? So static analysis is Git generally not added in the developer flow, but is added to the CI/CD flow, right? Once it could be added to, for example, a post commit hook, for example, or a pre commit hook also, and then those errors could be flagged. And when multiple people are committing, once you are ready to cut a release, once you cut a release and before it gets pushed to production, is another a place where you can actually run a static analysis. So this will actually help you improve the quality of your code, because you can use these automated tools. Last but not the least, which is even more involved, is profilers. Right? Profilers actually, so you had the linter, then you had the static analysis, and then the profile. Profiles actually runs the code, right? So now it can run the code either in a developer kind of sandbox, or it can, and then it measures different kind of usage of different kinds of resources, for example, memory, CPU, network, and so on. And then there are two kinds of profilers you can have. You can have a sampling profiler, which basically does not, every time a function is called, it might check certain metrics, right? What function called, how much time did the function take to complete, what were the parameters passed in, were there any errors. So all of this is taken all of this data is actually gathered, and then it is sent. So sampling does sampling, and instrumentation actually can run on also in production, but typically it's not run in production. It's run in whenever you're running a test and you're exercising the code. You actually run a code profiler, and sometimes also like a code coverage tool in parallel. So code coverage will tell you how much part of the code is reached, whereas code profiler will tell you how much of the resources are used. So between them, they actually give you a complete operating context of the program that is getting run. And there's some open source as well as proprietary tools that do code profiling. And examples could be include, like GNU profiler, group profiler, which is typically run in a developer workflow, or O profile is typically run in production. Like, for example, you are seeing certain kinds of memory leaks, or you're seeing the memory usage actually spike up. This is a very good way, a very good place to run something like O profile in production, and it will actually tell you where are all the problems that are there. So I have covered the first part, which is code, and that let me slowly move on to the second phase. And I will not spend a lot of time on this, because again, I said, like, other speakers have spent a lot of time, but because I mainly worked on distributed systems, I want to talk about three different things which kind of segue you into the next part, which will come in deploy and production, right? The first one is a bit load testing. Load testing is very very important, especially if you are building server software, because you need to know what is the breaking point of the software, right? A good example is something like AirMeet, right? So AirMeet, on which we are actually having this conversation. Let's say they want to find out if the software that we built can scale maybe to 100, 10 users, 100 users, 1,000 users. What is like a good ballpark, right? At which the system will start showing strain. And when I say the system, there can be different sets of microservices that it is made of. It could be like an authentication service that could fail first. It could be like the video service that could fail first, or it could be a screen sharing service that could fail first. So when you're looking at a holistic system, it's like a chain. And when you have a chain, you need to in the load testing, you need to find what is the weakest link and then work on it, and then actually you increase the resilience of the software. So you find those degradation points, and then once you find those degradation points, you can also run it with the profiler, right? So it will tell you all the resource usage. Is the resource a constraint, or is the way the software is written that's a constraint? Then the way software is written, that is a constraint. Then you can do refactoring of the code. Or maybe sometimes, like I've done is I've gone back to the first principles and actually rip it off that piece of software or that microservice and return it in statically compiled language, right? So as you grow, you'll see this points of degradation that are there. And sometimes what happens is, especially when it comes to, I talked about thread safety, you might actually find timing issues in code, right? Because now the system is so overloaded. This is a great time to find timing issues, which you never will find in any kind of developer workload. So this is super important, right? Because it will help you model performance as for example, staying with the case of AirMeet, like as the number of users actually slowly increases. And if, let's say, for example, whatever reason, right, certain services are failing and CPU is spiking, you can also design for graceful failure. For example, what I can do is I can and you will have seen this, for example, if you use Netflix or other kinds of thing, you can actually degrade maybe the quality of video, and maybe that might help you handle a lot more use. Or if that is even a problem, then you can actually switch off video, and then at least you can have the audio. And you will see these kind of systems as a user, and this is what I'm talking about. They have people who have built a system, have thought a lot about this load testing part. um, so when we build complex systems, right, and as the company grows, it is just impossible to kind of and this is something that also LambdaTest actually helps with, right? It's just impossible to model all of the scenario, right? Because there is a combinatorial explosion, right? Of interaction of different points, and then each of the different microservices or systems uh, will have different failure modes, will have different memory requirements. Maybe they are running on different system, they are written in different languages. So how do you test such a complex system, right? That is so if you can build it and you do all of the basic tests, you do unit tests, you do integration testing, but what you need to do is how is to model. So what you want to do in testing is model a scenario that you will see it in production, right? And then be able to kind of build a trace, either by capturing the inputs, or capturing the packets, or capturing the callie caller graph. And there are various ways to do this. Either you can use intercepting agents in production, or whenever you run a test case, you can actually use this. Or if you do manual testing, you can use a manual test to capture a trace. There are various ways of getting traces. There are various tools, and you can simulate and exercise the APIs and microservices using tracing, right? So in tracing, what is different from normal testing is you have an input, and that input triggers another input in another microservice, other part of the system, and so on and so forth, right? So you can actually test like the entire system, maybe like in different combinations as you go through. Like for example, the flow for a logged in user, a flow for a premium user, a flow for an unauthenticated user. This will trigger different different microservices and different systems, and then all of these traces will actually help you test this. Another super important one is like fuzzing. I cannot again, fuzzing was not that common maybe like 10 years back. Again, it had a very limited context, but I think if you look at where the world is going and how interconnected we are becoming, like whether it's IoT services, whether it's audio video, whether the quality of broadband, we're getting more and more interconnected, right? We have like speakers that are activated with the voice in our home, or lights that we can control using an app. So everything is getting interconnected, right? And what that means is the attack surface that a security or a hacker has, a black hat hacker has, is large, right? So, and typically what they do is they will actually try to give you invalid or unexpected input or sequence of inputs or sequence of invocations that can lead to crashes, that can lead to giving you escalated privilege, or it can cause potential memory leaks, right? So it is important to do this fuzzing for security testing, random failures, crashes, especially in a microservices led world, where because each service is independent but also dependent on each other, right? So super important to do, especially if you are doing the bare minimum, right? You're not doing fuzzing for everything. I would say anything that interacts with the external world, or anything that takes input from the external world, for example, network or protocol parsers, or disk or config log parsers, those for those kind of things you need to have fuzzing at least. So that is the bare minimum you should do. In the next part, I'm going to talk about deployment. Again, there are various ways of deployment and CI/CD, but I'll talk about how deployment can help you build a moat and help you actually reduce production failures. And the two parts that I'm going to talk about. The first part is canary test, and the second part is blue-green deployment. Right. So what will happens in a canary test, like and the name canary, I'll tell you, there's a very interesting story where it comes from. So for example, when miners used to actually dig under the earth, typically when you do mining, there are, in addition to what you're mining, there are like sometimes noxious gases, that toxic gases are released. And how do you find out whether those gases are released? So what happens typically is that a canary is lowered into the vent, and if the canary is alive, when you kind of pull it back up, that is when you know that everything is all right, and then the humans can go in and do that. So basically, canary is a way of testing an incremental push of code to a small group of end users or servers, and then saying whether it can monitor for failures. And why this is important? Because as system based become more complex, it is impossible even with tracing to know what are the conditions that will be in production, right? And then sometimes if it is a mobile app, users may or may not be aware of changes. And sometimes this is done in a very structured way, right? For example, if you're building apps, whether it's web apps or whether it is downloadable software, right? For example, even things like like the Firefox browser has this nightly builds that you can use, and they are buggy, but what it does is every time there's a crash, it collects all of the information and posts it back, right? So if you're a developer, you want to contribute to software becoming more robust, then you can use this. So Rust compiler has this, like even a developer tool like Rust can have this, or you can have like a desktop browser can do it. But this can also be used in server deployed or SaaS software. A very specialized case of as you grow bigger is to have different kinds of rings. So the first ring is, like, say you deploy to 5% of the servers, right? Those are the canaries. If that works well, then you go to the next stage. You look at the early adopters, right? And those have, like, maybe say the beta or the alpha channel, and then they give you feedback. So every ring that you go, the software becomes more and more robust as more and more testing is done. So what you're doing is, you're not testing doesn't stop with your um, in-house thing, not with your QA team or with tools. It actually, what you're doing is you're outsourcing, for a lack of better word, testing to the outside world, and then using this ring, you are actually reducing the impact of the blast radius, right? Because at any point, if the canary fails, you have always the option to revert back the software, figure out that what went wrong, fix that issue, push the canary, and keep on doing this iterative feedback loop as you push it through the rings, right? So you are basically using a human in the loop sometimes, or sometimes automated checks to do this testing. Another popular way of doing testing, which is come up and which is becoming more common, especially with Kubernetes, is blue green deployment, right? So what is so blue and green? Think of it as production and staging. So what happens is, you first deploy all your software on staging. You run it, maybe also run a beta channel that we call a canary. So you can sometimes use staging as a canary as well. And once you're kind of confident that you can actually switch to live, all you do is you completely switch between staging and live. So basically, at all points of time, you are running two identical infrastructures pretty much, The only difference between them is like maybe the data and some amount of code. And then you flip, basically keep on flipping, right? Like staging becomes live, live becomes staging, staging becomes live, live becomes staging. And as you go and as you rotate, you can do blue and green reply. And the best part is, because you have a route, you have a router in front which can switch between these two. If you feel that okay, when you make the staging live, production is kind of facing some issues, either some error metrics are going up or resource usage is going up, users are seeing errors. If any of this happens, you can just change the configuration of router, go back to the old code, then you go back and fix. So this is another way of what is known as blue green deployment, that is popular, that allows you to reduce the risk when you actually go down to production. Now all of this is great, right? Now you have done blue green deployment, the code is out there. Does it mean that you caught all of the bugs? No, right? So how do you, and even if you may not have a bug, but you want to also see the performance, right? You want to see how your code is performing out there in the real world, right? So there are three different parts that I'll cover. Is one is application performance management, or APM as we call it, log analytics, and then third one is distributed testing, which is an extension of what I talked before in traces. So quickly, what I will do is I'll talk about application performance management. So I talked about profiling, right? So think about it as code profiling in production, but with sampling and with real world performance, right? So you will have an agent running, or you'll compile the code with either binaries, whether it's Java, whether it's JavaScript, or even if it's a compiled language. And once it is out there, it will continuously sample. Basically, it will sit between the interaction and see what interactions happening, what are timing issues, how much time is the database taking to respond, how much time is this function taking to return, how much time does it take to, for example, authenticate, how much time does it take for you to for two services to interact, for two services to talk, so on and so forth, right? So basically what it does is builds up a beautiful profile of who is calling whom, how much time each one of them is taking, what is the sequence in which they are calling each other. So what you have is, once you look at the profile that is generated, you have a 360-degree view of how your code is performing in production. Let's say stay with, for example, AirMeet, right? If you run like an APM in AirMeet, either use something like Azure App Analytics or App Dynamics or New Relic, you can use any tool. It will tell you how it is performing production. So for example, as you scale the number of users or even number of customers, you can see what parts of a system are actually falling behind, or not performing as well, or are causing errors, or something different has happened in maybe a new customer that you have done, and the way their software interacts with your system is maybe different, and that is causing maybe the error rate to go up. So basically you will figure out where your model that is that starts with the developer's mind in code, actually how is it actually performing in production, right? So it kind of helps bridge that gap. Similarly, the another way of doing this is log analytics. The difference in log analytics is in the way it is done. So what log analytics does is it helps you find all of these issues that are there, and you turn on logging, and you can turn, there are 7 or 8 different ways of logging, and you can turn on this logging. And what it does is, like, the multiple popular ways of doing this. For example, there's like Azure Data Explorer, which allows you to do the log parsing, or even if you want open source, there is what is known as the ELK stack, which is Elasticsearch, Logstash, and Kibana. So Elasticsearch is like a search-based database which can index all of the data. Logstash takes all of the logs, parses the logs, puts it in a format that can be indexed in Elasticsearch, and Kibana is the engine that allows you to build alerting and performance dashboards on top of that. If you were to look at something like a Azure Data Explorer, what it does is it does the same thing. It pulls in the logs from various sources, it parses the logs, it constructs this search or index database that you have, and then what you can do is you can combine it with metadata, right? So for example, let's say I have a multi region setup, right? Like I have customers in Latin America, in Europe, in Africa, in India, Asia, and also in North America. And I want to know, when I'm deploying my software, how are people across the globe experiencing, are they experiencing network latency, are they are they using my software differently, are different tiers of my customers using. Like for example, in a SaaS world, you have different tiers. You have like the free tier, you have the premium, and then you have maybe like the Excel or the extra premium, and then you have the enterprise. Right? Let's say you have 4 layers, and you might have different sets of services and different sets of features that are targeted toward each stack. Now, essentially, what that means is every customer in each of these categories will interact with your software slightly differently, right? Though the software is the same, different parts of the software will get exercised in different ways. And you want to know this, so log analytics can actually help you meld all of this data together, where which so you can look at a customer and look at his you can layer that onto the log, and then you can figure out how that particular group of customer is actually performing, right? So then this helps you optimize your software and your resources as well. So these kind of systems are very important, because let's say as you start with a dynamic system, and then for example in my own experience, in one of the logistics company I worked with, we started off with Ruby, and then we realized, oh, this inventory system Ruby is not performing really well, so let's rewrite in Java. Then when we rewrote the stuff in Java, we realized, oh, this IoT system, Java is not very responsive, so let's rewrite in Go. Right? So these kind of large architectural decisions, if you want to make, I think log analytics and APM is like a good way of kind of squeezing more of the language ecosystem. So if you see, this is actually giving like a creating a nice feedback loop between the different systems that are there. And the last one, I'll before we kind of stop for questions, that I want to talk about is distributed tracing, right? um, so I said, like, there are different kinds of customer, there are different microservices. uh, every kind of request, every kind of interaction can have a different pathway through a system, and maybe sometimes certain pathways is giving rise to different errors. It could be because of the way the software is set up. I think it could be a configuration issue. It could be the way users and or the front end is interacting with the back end. It could be the way the users are using the stuff, using your software. It could be uh, some kind of code what do you call assumptions that have actually gone wrong, right? So each of these could be whenever certain pathways are exercised, how do you figure out what is the pathway that is causing maybe errors? Like for example, certain kinds of queries certain kinds of users are causing certain kinds of queries or database slowness, right? So what are the pathway they're coming through? Or is authentication slow for certain kind of users, maybe single sign-on users, maybe with a certain customer? Now, whenever you do this integration, they will follow different pathway to your system, right? And then if a certain customer complains, obviously you have log analytics, and you can look at log analytics, you can look at APM. But if you want to look at a particular request from the origin, which is like a mobile app or web app, right up to the database and back, you want to look at that flow. I think distributed testing and tools like OpenTelemetry, Jaeger are like really useful, because you can start off with the request, trace it through the API gateway, through the account service, to the inventory service, to the shipping service, and to those databases and back, right? And then you can do it for different kinds of requests. It could be, as I said, like for authenticated users, there's a different flow. For unauthenticated users, there's a different flow. There's a different flow for premium users. There's a different flow feature set for enterprise users, and so on and so forth, right? So anything that leads to errors or a high latency, you can actually tag those requests, and then you can trace how they go to the system. And what distributed tracing does is not only it captures this, but it gives you a visual way of figuring out what is going wrong with the system when customers are actually going through. So in summary, I would say, uh, again this is like a cycle, right? So choose a proper language for your stack. Use tools in your developer and CI/CD workflow. Insert testing into your CI/CD workflow, and I am sure other speakers also emphasize that. Deploy intentionally as you grow to reduce the risk, and keep eye on production using distributed testing, log analytics, and APM. Right. So if you look at this, the last, when the production actually influences your stack and vice versa, right? So it's a continuous cycle. So that allows you to evolve your software and your stack and your product in a very, very graceful way, rather than having catastrophic failures, right? So this is a way of reducing risk and looking at it holistically, right? So that is all I wanted to cover. So with that, I think we have some time for questions. So if there are any questions, I can actually answer those as well. And you can find me on Twitter at Vinayak H, and on LinkedIn as well.
Great,
Cool.
Vinayak. The specificity of your suggestions was ruling the session, and I really loved it as always. And yes, you have a lot of questions, so let's take some of them one by one. Here is the first one. Vinayak, as the CTO of a startup, when do you add QA professionals to the team? I've seen many startup companies hire QA after a few years. In that case, how do you set up the QA process to deliver quality product?
Okay, great question. I think as a CTO of a startup or even an early engineer, right? I think again, like I'm not very religious about it because it depends on the product and context. But you should ideally you should have like test-driven development. If you are not doing test-driven development, at some point when the product has traction, and when you start getting users, those users are actually paying you for software to work reliably, right? So if you're not actually setting up a QA team, or I would not say a QA team, because I think software quality is not just the job of the QA team or the production. It is also the job of developer, right? So as a CTO, always I see that certain teams are, I would say at loggerhead, but there is this what I say creative tension, right? And two of those teams are dev and QA, dev and product, and also dev and DevOps, right? So dev and QA, because the incentive of the QA team, sorry, the developer team is incentivized to push features. So is the product team, but DevOps and QA team are both incentivized to keep it stable, right? So now you have this duality in that, right? So I would say that point differs, right? Typically I would say maybe if you are around 15 to 20 people and you feel that okay, the developers are spending a lot of time writing tests, and then your software is getting more complex, you need a dedicated QA team. And so I think I would say again that can be different depending on software. For example, if I'm in a healthcare domain, I think the quality of software, or fintech, quality of software, the quality of security should be much higher. So I would probably hire people in security and QA team much faster as a compared to, like, if I were building like a logistics or a consumer facing app, where okay, if the app doesn't, app fails, or the of the user gets like a failure, it's okay, right? I can live with it, but not with the healthcare or a fintech domain, right? So that domain and the product also defines that point. I hope I answered your question. I mean, answer is it depends, right? But I'm giving you some pointers as to when can you make that decision.
You're fantastic, and loved what you said about the shift left as well. That it's your devs who are actually doing the QA job from day one, and as you mature, you have to kind of hire specialists and create specialist teams. So loved what you said. Totally with you on that, Vinayak. Let's take the next one. Very specific question. Okay. So Tamalika here has a question: how do we avoid flaky test cases? And this goes back to the testing now maturing, focusing on flakiness. What's the way forward?
Yeah, it's a again there's it's a very tricky question, right? Because um, multiple, I think that two, right? One is like flaky test cases, and the other thing is documentation, right? It requires significant effort to keep them in keep them in sync, and it also boils down to culture, right? Because you need to have ownership in avoiding. Obviously tools can help, but tools are only as good as people who use the tools, right? For example, if you have flaky test case, like if the dev says, okay, I know this is flaky, this has been flaky for a while, let me live with it, no tool can help you, right? So yes, I think ideally I would say that the way I have done that as a CTO is uh, a regular review for the QA team to figure out which tests are failing and why are they failing. Are they even relevant? Like sometimes the features themselves change, so even the test cases may not be relevant, right? So you have to kind of constantly revisit, and it's very similar to the way to handling this is very similar to how you would handle tech debt, right? It is something that needs to be done, may not add immediate business value, but if you take pride in your product and your code, as a team you have to figure out ways of doing it. Either you have like specific sprints and you fix those flaky test cases, or you have like a barrier, you like have like a hackathon and do that, and I have done both in my own career.
No, great. I loved it that you didn't just mention few tools. The culture of living with flaky test cases, addressing them upfront, very, very important. Tools can't really help with that. Thanks a lot, Vinayak. Let's take next one. This one is from Mani Seni. What should be the level of language proficiency, beginner, intermediate, professional, when you are starting as an automation engineer?
Interesting. See, honestly, and I'll probably making a comment on the Indian ecosystem, so I'm being recorded. But I always felt as a CTO, I started as a dev, a backend dev. I always felt that automation is not given its due, and I would say that language proficiency, at least I would say intermediate, because if you don't understand what that piece of code is doing, right? Because the developer has a mental model, right? And you as a QA person are obviously writing automation test cases, but you're also trying to break that mental model, both as a QA and as a security tester. So knowing where you can, where those bugs are creeping in, you need to have at least an intermediate level of language understanding, intermediate level of not just the language but also the system and the way the system is worked. So I would say, especially if you want. Especially if you want to work in one of the like the big tech companies, I see that one of the reasons, I mean, there are obviously other businesses. One of the reasons why they've become big is they've been able to invest and focus on on the amount of tooling that goes into automation and the quality of engineers that is there. Yeah.
Fantastic. There are many more questions, but we have really hit the top of the hour here. Vinayak, and lovely. The insights, specificity, very, very pointed, very, very directional. I'm sure everybody had great amount of notes from this session. Vinayak, we are privileged to have you today, and all of the community members who could join. Privileged to have you today. Thanks a lot for taking out time and talking to all of us. And to the rest of you who are tuned in, continue the day. More sessions for you. Thanks a lot for joining this one.
Thank you for having me. And yeah, if you have any questions which I can answer, I think tweet at me at Vinayak H. That is my first name and first letter of my last name, and I'll be happy to answer on Twitter as well. Thank you so much. Thanks, Mohit, for having me. I hope it it went off well. Yeah.
Been a pleasure. Been a pleasure, Vinayak. Okay, great. Thanks a lot. Bye bye, everyone.
Thanks. Bye. Bye, everyone. Have a good day.